Welcome back, everyone, to today's explainer. Let's just jump right into it, because today we are unlocking the secret to loosely coupled, highly maintainable, and honestly, just thoroughly testable code. We're talking about mastering dependency injection, or DI, specifically looking at how it all comes to life in ASP.NET Core and .NET 8. So if you've ever felt like your classes were just hopelessly tangled up in each other, or hey, maybe you're gearing up for a really tough technical interview, you are absolutely in the right place.
Okay, let's dive into this. To really wrap our heads around dependency injection, we actually need to step away from the code for a second. Think about this highly relatable analogy from John Munch. It's kind of like explaining architecture to a 5-year-old. He says, when you go and get things out of the refrigerator for yourself, you can cause problems. You might leave the door open, you might grab something mom or dad doesn't want you to have. What you should be doing is stating a need. Something like, I need something to drink with lunch, and then we, the parents, make sure you get it. In software, your classes shouldn't be rummaging through the infrastructure fridge. They should just clearly state what they need to function.
Here's our roadmap for this explainer. First, what is dependency injection? Second, DI versus the service locator. Third, stable versus volatile dependencies. Fourth, understanding service lifetimes. And finally, best practices and drawbacks. Section 1. What is dependency injection? Stating a need.
So at its core, dependency injection is a design pattern where an object receives its dependencies from an external source, rather than creating them internally itself. It perfectly implements what's known as inversion of control, or, as our sources playfully call it, the Hollywood principle. Don't call us, we'll call you. Basically, you have to stop using the new keyword inside your classes to create dependent objects. Instead, an external injector hands those required objects right over to your class.
Now, what's really fascinating here is just how much fear, uncertainty, and doubt, FUD, really surrounds this concept. Let's bust some of these common myths based on the source material. Myth 1, it's only for late binding, like swapping out a database engine. False. It's actually about overall maintainability. Myth 2, it's only for unit testing. Also false. Now, sure, it makes mocking a whole lot easier, but that's really just a happy byproduct of good design. Myth 3, you absolutely need a specialized DI container. Nope, you can actually do pure DI manually without one. And myth 4, it's just an abstract factory on steroids. Absolutely not. DI asks you to supply dependencies, not to query a factory to go find them. The architecture brilliantly illustrates exactly what we're talking about. Think about a main method that acts as our external source. It steps up and takes full responsibility. It creates a console message writer, and then it injects that writer straight into a salutation class. So the salutation class has absolutely no idea how the message gets written. It doesn't care, it just knows it has an iMessage writer to use. It stated a need, and the main method fulfilled it. Simple as that.
Section 2, DI versus service locator, the great debate. If you take away literally just one thing from this entire comparison, let it be these two verbs. Dependency injection is to give. We give a window and a door to a house object. The service locator pattern, on the other hand, is to take. A class asks a central locator container to give it a house. Dependency injection explicitly reveals what a class needs right up front in its constructor. A service locator kind of hides those needs behind a generic request to a container. This really gets to the heart of why the service locator is often considered an anti-pattern. If you're executing manual service resolution, basically grabbing dependencies straight from an IOC container inside your class, you are hiding your dependencies. And here's the kicker. If a required object isn't in that container at runtime, your application just crashes. DI avoids this whole mess by making sure the container creates the object first and then gives it to the class. That way, if something is missing, you know immediately upon object creation, not, way deep inside your application's logic when it's too late.
Section 3, Stable versus Volatile Dependencies. Categorizing our code.
So, the absolutely crucial point here is this. You do not need to inject everything. Stable dependencies, things like basic string manipulators or standard .NET-based class library types, they're totally deterministic and perfectly fine to just use directly. But volatile dependencies, that's a different story. Things that require database setup, talk to external resources, or rely on random numbers or the current system time, these are the true focal point of DI. These are the exact pieces that require us to build seams into our applications, just so we can maintain testability and flexibility.
Section 4, Understanding Service Lifetimes. Managing Object Scope in .NET 8. Okay, in .NET 8, you have 3 primary lifetimes to choose from. And heads up, This is pretty much a guaranteed question in any ASP.NET Core technical interview, so pay attention. First step, Singleton. Just like it sounds, the framework creates exactly one instance of your service, and it shares that single instance for the entire lifetime of the application. Second, we have Scoped. This creates one instance per HTTP request, which makes it absolutely perfect for things like database contexts in web APIs. And third, Transient. With Transient, the framework creates a brand new instance every single time that dependency is requested or injected. Now, this brings us to a really critical warning for .NET developers. You have to choose the appropriate service lifetime. Otherwise, you're looking at memory leaks or just really weird unintended behavior. The sources highlight a massive pitfall here. And yes, this is another classic interview test. It's called captive dependencies. Basically, if you inject a transient service, which remember is supposed to be short-lived, into a singleton service, well, that transient service becomes trapped. It gets held alive for the entire life of the application by the singleton, which can lead to severe memory leaks and data corruption. So always be mindful of your object scopes.
Section 5. Best Practices and Drawbacks. Achieving Balance in Architecture.
All right, here is your actionable checklist based on the sources. Number 1, always leverage constructor injection. It's the gold standard because it explicitly declares what a class needs to function right out of the gate. Number 2, always inject interfaces rather than concrete implementations to keep your code flexible. Number 3, please don't inject raw configuration strings. Use .NET's options pattern instead. Also, if you're registering multiple implementations of the same interface, .NET 8 has this great feature called keyed services. Use them to resolve things cleanly. And finally, avoid that service locator anti-pattern we talked about. And if you have really complex setup logic, just use factory methods. But hey, keeping things completely objective here, DI is definitely not without its costs. As noted in the JetBrains guide, implementing DI inherently increases complexity. It can actually make your codebase a bit harder to read, simply because the execution path isn't strictly linear anymore. You've also got a slight performance overhead from resolving those dependencies dynamically at runtime. Plus, there is undeniably a steeper learning curve for new developers jumping into your project. And if dependencies are misconfigured, it can lead to some truly frustrating runtime errors that are, frankly, a huge pain to trace through a massive dependency graph. But despite those drawbacks, dependency injection remains a foundational pillar for building robust, modular applications today. Which really leaves us with one final, very important question to consider regarding your own codebase right now. Is your code cleanly and explicitly stating a need through constructor injection, or is it still blindly rummaging around in the application infrastructure fridge? Take a hard look at your architecture, apply these .NET 8 principles, and just watch your code quality soar. Thanks so much for joining me on this explainer. I'll catch you in the next one.